Like I said, it's a little bit standalone. So the digital twinning 7 steps to digital twins. How do we do that? And what do we mean with this? And like I said, going a little bit easy, as a reminder, we start with the why. And already when you look at these examples here, areas in which we work actually, you see that the why might, of course, be very, very different. On the one hand side, we are talking about these digital twins that are at the heart of tomorrow's systems. We are talking about smart buildings. We are talking about maybe indeed seafaring vessels, which have extreme situations which they have to handle. We talk about the smart industry with the example here of ASML close to me in Eindhoven, or the Port of Rotterdam, the protection of critical infrastructures, which digital twins, where you have a resilience problem, where you say, I go from prevention, preparation, response, and recovery for basically everything which is sensibly expecting to happen, just to say that this infrastructure has to work. And obviously, this problem of protecting the Port of Rotterdam against flooding, a disaster, whatever, is very different from a smart building here with the examples of Signify, so the former Philips lighting division, building a smart lighting system in the edge building and basically reducing your energy bill. So in that sense, for the most of us, these areas will actually be less important than maybe this one in the area of the manufacturing industry. But also there, we still see that the why of the digital twin is extremely wide. It could be about smart logistics, adaptive just in time, having a fitting inventory to the task at hand. It could be about the scheduling on the factory floor, about the monitoring of the equipment there, really that you say less consumption, more sustainable, and optimization, reducing waste, all these things. But it could also be about model-based control, flexible manufacturing, made to order, that you have lot sizes of one and a low change over efforts between production ones, that the programming of the machines is low code, no code, and that you actually say, okay, this is with the digital twin maybe several times faster than it was before. And of course, very often it's about preventive maintenance, downtime prevention, that no machine which is in the critical path here for this production ever goes down in an unscheduled way. Of course, maintenance will be needed, but not as an emergency response. That is, of course, something we are after. Now, with all of these digital twins, we know that they are not free. It is an effort to build something like that. And even if I contradict at least one of the speakers of yesterday, we don't believe that it is always that easy. You have to have a little bit of technical knowledge here. You have to invest time. You really have to know what you want. So the why, starting with the why, is critical, but also the technical expertise to do it, to make key decisions yourself in a company. So if you advise a company, then of course it's a digital innovation hub. You need the technical expertise to also tell them what decision making in the company will actually mean, so that they are also confident that they own the decision, that this is not blindly following, but that this is actually something where they say, okay, I get it. This is what I can do in this company. So that is then where you say, okay, because I understand, I can do this investment. And the return of investment for the digital twins, if done right, is normally a large one. I give you some examples here. Consumption numbers going down 10 to 30%, fuel for vessels, for example, energy bills. This is significant. So a business model of Philips here, for example, is indeed to say, you don't pay us, but we get the money that you're safe in energy. So they are that confident in earning it back that they can make a business offer like that. Preventive maintenance very often has a return of investment in the first year, which was already over 100%. So this is an area where taking the step towards the digital twin pays off, but you have to do it right. And starting with the why is the right thing to do. And that is why we said it is entitled to its own rationale. The why is so important that you really have to get it. And this is why we developed the Change2Twin Compass tool. Laura explained all of that to you, so you know it. However, I'm taking it over from here. The why connects your business and the KPIs that you are describing in this analysis with the digital twins purpose. Now here in gray on the lower side of the slide, you actually see these KPIs. So we have many in this tooling, in the Compass tool, which basically then say in the analysis, you know that certain items are of critical importance to that company. So from there on, the why analysis basically says, okay, then these are the purposes of digital twins which should be pursued here. So for example, if downtime should be reduced to an unscheduled downtime 0, then obviously preventive maintenance, diagnosis, and these areas are critical to you. If, on the other hand, it's about the consumption of energy, well, then it's monitoring and optimization, which of course also goes in the direction of best quality. You just optimize for a different goal. But of course, it might be also something very, very different, like customer engagement, virtual design, commissioning. So the first steps of installing a system on a site, all of these things, different KPIs, different why, different purpose. And that is something where we start with today. So when we say these purposes differ greatly, and then we basically structured it in a set of typical purposes. The first 4 you see here. So the virtual design is basically when the digital comes first into being. So that this is really about all the places where they say, okay, I want to know what the system will be. I want to design it in the right way. I want validation before I build it, all of these things. And this is actually one of the areas where my own organization, ESI, is very strong in, that we say, okay, this building of systems in a structured way, the system engineering part of the full chain, this is our art and science. But of course, you can immediately go further from that. You can say, okay, customer engagement, the customer should see what they will get. And you have seen Unit 40 yesterday. I would say they excel in that. So you understand what will be there, which of course means you might have already something virtual which you can use for training, but it might also be the decision that a customer says, yes, this is what I want to buy. So if you have something like a flexible product where you say there's a lot of customization going on, a lot of options for the customer to choose, but it will be costly to change it later on, then of course this is what you do, virtualization together with customer engagement. The customer sees what they will get. Then comes the commissioning step. So first time on is first time right. This is something which you have definitely in areas like the smart buildings, where you say you have an awful lot of sensors. And all of them have their ID numbers and they have their mappings where you have to say, okay, this sensor is here and it's connected to that gateway and then it's doing this functionality, and of course it goes wrong. And a digital twin, of course, helps here, saying, okay, we really run it in an orderly fashion. We do it step by step. We know exactly if it's correct. And when we switch it on, we will not spend the next week hunting bugs in this installation, looking for flipped cables or something like this. But there are also very different purposes, like feedback to engineering. So you have the machines in the field, it's your product, it's running somewhere, and now you want to know something about it. Maybe you want to know why a certain machine fails more often than another. Maybe you want to learn how it's typically used to do the next iteration, the next generation of the systems more suited to the needs in the field. Maybe you want to estimate risks in safety critical areas where you actually say, okay, what do I need to protect myself against? All of these areas are something which is really a feedback loop towards the own engineers of a company. And also that is, of course, supported by a digital twin. Now, when we look at these areas, we can immediately see that the needs for the digital twin will also differ greatly. So if I just give you some nice examples here, in customer engagement, upper right, virtual design are indeed more like a drawing, upper left, but also, let's say, feedback to engineering, really seeing the effect of, for example, heat isolation by measurements outside the lab and just generating the data, or commissioning models, which basically say, okay, I'm basically simulating what I should see. I can see that I observe something different, and I can immediately say what must be wrong. All of these things are possible, and all of these things means this is a different digital twin. And of course, it is possible to imagine that there is a core of this digital twin which says, I'm the same, and then I have extensions towards certain purposes, certain user interfaces for different people. Commissioning is done by other people than the feedback to engineering, obviously. So it is possible to imagine that it's one digital twin which has different aspects. But we can also, for the sake of simplicity, just say, no, these are different digital twins, and we are building something different here, and it will look different, so the needs will be different. Now, the story goes on, so let me give you the list, basically, of the purposes we will investigating a little bit today. So the next one is basically when you say in operations, a fast response is essential. So monitoring, optimization, best quality problems, scheduling. This is this area, especially for everything where you have that smart in the name, the smart building, the smart factory, and stuff like that. And you will remember that my colleague Jeroen told you that digital twins are very much about a decision. They support decision making. I think this is where it's very clearly seen. They support it because they notify you something is going on. You, a human, need to respond, or if they go a little bit higher, but that is a smart system, they actually say, okay, I can handle this. Now, the picture in the middle is something in the area of preventive maintenance that I compare one system, the red line in this picture, to other systems I have seen in the past and actually say, okay, this is how the performance is degrading. I have seen this before, therefore I'm predicting a breakdown in that and that time span, which of course gives me the opportunity to schedule my maintenance earlier than that. Now, next to that, of course, we have the smart systems themselves when they say, okay, they adapt control. So this is the area where the system starts to analyze, starts to plan, and then executes an action and changes something based on the computations in the digital twin. So this is far beyond monitoring. This is far beyond giving you a picture of what is going on. This is decision-taking by the digital twin. Now, you can imagine that some people will say, hey, this is where the AI technology goes in, this is where the smart system is, where all the fancy stuff happens. And you will also find some people who say, well, you know, come on, this is control. We have done this for decades. So what is the difference here? And that gets to be very technical to say whether or not there's a dividing line in between. I think this is actually not important for us here. The fact is that basically the digital twin takes information that we would see on the slide on the left side and says, okay, the analysis and the planning is done in the computer, and the computer takes a decision. the digital twin is computing and not only showing, and then it takes an action. So with this, I can basically say, okay, if we know that, what is still the same thing in all of these areas? And of course, you have learned that yesterday, the digital twin mirror aspects of real systems, processes, or products. So I'm showing you one example here, which is in the area of preventive maintenance. And actually, Atlas Copco is one of the companies, a very, very nice flagship story about how to build something like this. But it's only an illustration. It will always be looking the same. The ultimate goal here is to connect the digital twin to data feeds, so that the digital twin can monitor, it can assess, and maybe predict of what is going on. But that will not be enough. You need the integration with business processes. So in the area of preventive maintenance, I think this becomes immediately obvious. If the digital twin tells you that this system is on a decline, that its performance gets more lousy and more lousy and more lousy, so that in 5 days, if things continue like that, it will not fulfill its function any longer, and within 10 days, it will most likely break. You know that a service team has to take an action. The digital twin is not going to do that. Therefore, the integration with business processes is obviously the crucial item here. So someone who tells you, I will build you the digital twin, well, that still means that the company who has the digital twin has some work to do here, and that needs to fit. And all of that is indeed in the 7-step story. So this is why we built a roadmap. The 7 steps that we say, okay, we have a certain blueprint because there are similarities, but the journey to do so is definitely not the same for everyone. So even though I could tell it here for a single example, and you would think this is how you do it, I still urge you to understand, from the point of view, especially of the digital innovation habits, if you give advice, it is not the same for everyone. Very strongly, of course, you see this in the part that digitalization efforts could be part of a large transformation. You could indeed say, hey, this company is going into a new market with smart products. They never did something like this before, so this is a major change. Or it could be that you just say, the company wants to avoid waste, and they have chosen the digital twin technology for monitoring to do this better, so it becomes more sustainable. They are responding maybe to a requirement by law, but in essence, they want to do the business they always did, but they make it more sustainable. So that will not be the same game. But in the same manner, the starting point is also very different between companies. There will be companies where I go and say, okay, what do you have? Do you have, for example, engineering models of the systems that you want to monitor? If so, it might be an easy transformation, a relatively easy transformation, to go to a digital twin monitoring them, because you have all the understanding of how this system works in a computable, readable form. Or you might say, no, greenfield, this is about the next generation, and I never did anything in a digital way. So let's start with everything from virtual design towards the digital twin, with nothing in legacy, with nothing which I have to consider, just rolling out the best possible way for the future. So very different starting point, very different approach. But another thing is, the journey has its own needs too. And the digital innovation hubs, they will differ here. Some of you, I assume, will actually offer very technical advice. Some others will look into business processes more strongly. And some others might actually have a strong angle for change management as well. Innovation normally means change. And with change, you are on a journey. that journey has its own needs. I give you some of them here. It's basically the management is all in. If management is not supporting that, then normally the journey fails. Communication, obviously, open and bidirectional, people listening. Competence for decisions in-house. Now, the digital innovation hubs support, the digital innovation hubs advise. But in the end, it has to be someone who says, I'm going to do this, I'm going to sign this. And at least that inner gut feeling of, I'm confident because I understand enough, or that feeling of, oh, wow, this is so complicated, I cannot sleep. So this is now that I know I need to learn more. That kind of competence for in-house decision doesn't mean every technical detail. You can outsource that. That is what the innovation hub with the marketplace is for. But decisions are taken by people in the companies. They have to be familiar enough with this. Then, of course, you do it for the end user and you do it with them. A digital twin, which is showing information, and the management looks at this and says, this is a beautiful picture. And then the service people say, yeah, but it's not showing what I need for preventive maintenance. That is a failure. So with the end user, what are their needs? How are they thinking? What can they cope with? That kind of story. And then indeed it is about change. So help everyone on board. Digitalization like this, digital twins, might very well mean that some people fear for their jobs. That some people say, I'm going to be left behind. This is new computer fancy stuff. I don't even have a PC at home. What are you talking about? I don't want this. So it's a company's responsibility to say, guys, we are doing this together. There is training. And then, of course, the digital innovation hubs can also offer support in this. But help everyone on board, make that clear to the customers of the digital innovation hubs. It's a journey, and a journey has its own needs. So they have to think about this. We actually wrote this down. So this picture on the left here, the Ready for Digital Twins, that's a nice flyer. I think it has a nice level of abstraction here. It basically doesn't assume too much. It starts with explaining what all of this is about and what I just spoke about, basically this intro, which I now gave you a little bit on paper form. It explains this 7 steps method, which we are following here. So in that sense, it's a little bit of easy reading, and I advise you to use it. And actually, the 7 steps are listed here on the right. And we definitely talked about the start with the why enough, so I will not go into that any further, but basically run through these 7 steps now for the reminder of the presentation, and in that way tell you a little bit about how to approach it. And the first one for this is actually the asset selection. Now, the asset selection is about the physical twin. And like I said before, digital twin mirrors aspects of real system processes or products. So this is a choice. So even when I say I'm staying in this example of manufacturing, I could mirror the logistic chain, the shop floor processes, the machines on that factory floor, or I could mirror the product and say this is about the control of the machine, which has to be digital, but the twin is about the product. So what do I choose? Which asset is the one that I want to mirror? And from that asset, which aspects are essential? Even if I twin a machine, do I do this for the purpose of maintenance, or do I do this for the purpose of control, or do I do it for both? So that's a decision. So asset selection, the physical twin, that is basically the first step. And after that, we are already going into the realization of the digital twin. So now we know what our physical twin is, and we want to start building. We have 2 aspects in this, and these are the steps 3 and 4. The infrastructure and the twin building. The infrastructure is about the data flowing from the physical twin towards the digital twin. So bringing the sensors live, enabling information flows. So here we see terms like IoT, the Internet of Things. So basically the technology which is readily available to connect from sensor towards the data distribution, maybe connect to databases, merge it with other information. So this is where the term cyber-physical comes in. Maybe you will find, oh, wait a second, I actually need to share data with some other people to be most effective. So then I have to talk about trust and maybe protecting my data sharing. So all of that is an area which is to be considered. And so you see here's this nice picture. And when I say it is to be considered, you already realize you have a choice here. Trusted data sharing might not be necessary. The cyber-physical connection to other databases might not be necessary. But if it's a true digital twin, having live sensors and having a data chain from the live sensors to the digital twin is essential. So this is the area where you say, okay, some of these parts you will need, and some others you might need. And remember when I said that this is about consultancy, that this is about understanding of needs, given a purpose, and mapping them towards technical options. This is where the consultancy comes in, to make that mapping. So in that sense, when I say here, these are 5 major items in the area of infrastructure and data transport, then my statement is they have to be considered if they are needed. And the answer can easily be no. And if the answer is yes, well, then let's look into it. Same with the data, also the road from the physical to the digital. So here you see the terms like the virtualization, but also failure modes and effect, a criticality analysis, the link between data and knowledge. So basically knowing that, hey, I have some models about my digital, about my physical thing. So this is what describes the physical object in the computer. This is the digital twin. But that sensor over here, that is actually providing data for that part of the model. So really understanding this mapping, it is sadly not often that straightforward. This is part of it, understanding what happens if something goes wrong in the system so that you can interpretate the virtualization itself, of course, but also some other items which are sometimes overlooked here. So this is why we like to have all these boxes on the paper. The one is to ensure fidelity, ensure trust. A running digital twin is a system. So treat it accordingly. If there's a company building system, they of course understand that they have to have quality control, that they have to have test runs, and so on and so on and so on. Same here. So if you're building a digital twin with someone, for someone, if you're helping them, plan accordingly and understand that the first go of the digital twin might still have some hiccups, bugs, things you didn't think of. Therefore, you test it, you get user feedback, you revise it, you make it ready, and then it works. And more importantly, see to it that people have a reason to trust it. So the big black box where then someone stands in front of and says, yes, it's screwing up the information that I should do a maintenance now, and I don't understand how it's doing that, and I don't understand why it's telling me that I'm standing in front of the machine and the machine looks fine to me. No trust, no action because of that lack of trust. The service guy might simply say, you know, I'm not opening this is running. So stepping away, and then it breaks down a week later and he says, okay, you were right, but I still don't get it. Why? So I don't trust. So in that sense, ensure the fidelity, but do it in a way that the people using the digital twin understand, yes, this is what is happening inside. This is why I can trust it. And that doesn't mean that they have to understand every detail, but enough to trust. Another area here, by the way, is then configuration management. So we have many customers in the high-tech domain. And there is this bon mot that the only constant for them, of course, is change. There are software updates to the machines, there are maintenance operations, the situation changes and stuff like that. So I have data over a certain machine, and I'm looking at the machine right now, and I say that doesn't make sense. I'm seeing a timeline for data here, but actually there is no sensor producing that data. How can that be? And then someone tells me, oh yeah, we changed the software, so this is no longer captured. Oh, great. So you are telling me that I'm looking at data which doesn't apply any longer for the machine I'm looking at. So I need to know the configuration of the machine so that I can configure the digital twin in the same way. So configuration management, also one of the items often overlooked, has to be taken into account. Now, with that, we can finally say we have a digital twin, and I can finally doing something. So operating the digital twin, live operation, and business action, steps 5 and 6 in the 7 steps method. Now, the digital twin is supposed to be always on and always in sync. But what does it do now? Our advice here, for example, is that there are certain parts of the digital twin which really should run autonomously, especially everything about detection. So if, for example, there is an anomaly, you're monitoring something and out of the sudden the numbers really don't look normal any longer, you want this digital twin to notify you. You do not want the situation that once in a day someone looks at the data and then he might notice this. And this thinking, of course, is something that everyone running machines is used to. This is about process control, that you are saying, hey, there's a certain bandwidth of fluctuation in my sensor readings which I'm willing to accept, and everything beyond that is so unlikely that I want a human to think whether or not we need to respond and to change something. So this is where areas like the Western electric rules play a role, and every expert will know that change detection, anomaly detection based on live monitoring, and then enabling process control, this is a well understood chain. Now the reasoning on, okay, what did just happen? Why do we see these numbers? Is this a problem or a glitch? Was this just unlikely? Or is this now something which really goes wrong and need an in-depth response? That is the area of reasoning, a root cause analysis. Now, this why question, that is something that doesn't need to happen autonomously. That is something I can do on demand after I was notified that something is going on, but that is a design decision. So you have to think about what is needed here, what are the response times needed for that and all of that, and then you build it accordingly. Similar, of course, with the point of prediction. So yes, if I have data coming in from the physical system to my digital twin, and the digital twin says, okay, this is a nice curve, then of course we have algorithms these days that just say, okay, then most likely this curve will go down like this and it will hit rock bottom within 7 days. And this can be very simple. It can be very elaborate with knowledge about the building blocks in your systems and everything. But prediction is possible. So what will happen in the future? But then, again, how often do you do this? Who picks it up? This is again a question of the design of the digital twin, but also of the business actions. So in that sense, everyone has to understand that they need to be ready to reap the benefits here, that they have to have business processes that consume the information. And I already gave you the example of the predictive maintenance, that it doesn't matter if the digital twin knew that the breakdown would happen if no service team responds to it. So a process that the company then might establish and saying, you know, when the service department opens up their computers in the morning, they get a report, and the report tells them, we are flagging 6 machines in the field now as please take an action, so start scheduling, stuff like that. That is a business process. It can be that simple, but someone has to have it. So the process that consumes the information that the digital twin provides has to be in place. And then assess your success. So digital twin, once numbers are generated, service department takes action. Was this always in time? Or was this hit and miss? Do we in the end find that the digital twin is internally seemingly rolling dice and maybe has an 1 in 5 hit rate and missing too many machines, which it should have been predicted that they needed service but didn't? Or is this a system which is dead on accurate and basically saying, no, I know everything which is going on here? So assess that, think about success criteria, build them in, and basically have now and then a revision of the success of the digital twin and whether or not, just like with any other running system, it might need an update. The interweaving of the live operations and the business action is, by the way, also a pretty interesting one if you use this picture here, which is, by the way, the MAPE key, so monitoring, analyzing, planning, and execution. So in that sense, when you think about it, does it tell you something about how to build the digital twin? And we believe it does. It will often be seen in a way that, yes, I'm giving you the digital twin, and now you have to do your business accordingly. But think about it. This is actually not smart. If, for example, your service department says, you know, my machines in the field are all over the world, and we cannot afford a service organization which has people all over the world, which means if you notify me, I have to get there together with all the right parts, and that takes 4 days. Well, then the digital twin better announces the need for service something like 7 days in advance and not 3 days, because then it is no longer possible to prevent the breakdown in time. So it's the business action in this case which says you have to be on that deadline, you have to have that forecast, then we are successful. And not the live operation that the technical guy says, yes, I built it and I believe it has a 90% accuracy on 3 days, but only 60% accuracy on 7 days. No, then you have to do better. Change the digital twin, because changing the business process so that it can respond to 3 days is by far too costly. So they are interwoven, but the business action might be the one leading the requirements for the live operation. So this is also something to understand here. And in terms of that, things change, which I already mentioned, just realize change happens. So this is cradle to grave thinking. Keep it alive, keep it useful. Step 7 of the 7 steps method. So there's this notion of a digital thread that weaves the traceability of the digitalization and the system from cradle to grave. Meaning that these items, which I mentioned earlier, data collected at one point in time, system description for another point in time, things don't match, that kind of stuff here. So that you know, sooner or later, this system will change. The digital twin has to change accordingly. Or you find a bug in the digital twin. Now it gives different advice. You have to understand that, for example, the analysis of your success rate changed at that point in time and stuff like that. So this is another step which we often seem to be overlooked. So change happens, and tell everyone that this is something which will continue. You build it once, you put your effort there, the better you are in that moment, the less work you will have over time, but you will have work later on. So this is not something where you go to a vendor and then say, yeah, install it, and then get out of my company, and I never need to see you again, and I don't have the competence in-house to touch it, so I will just trust it for the rest of my life. It will not work like this. But there's a benefit. If you do it like this, you're also solving a very, very strong problem in areas where systems run for a long time, and that is the knowledge management. Especially people looking at infrastructure systems, they face that they say, okay, we built this 30 years ago, we updated it 20 years ago, then we did a minor extension 10 years ago, and now the customer comes back and says they need another extension, but they also want a new update at the same time, and actually whoever knew what the system is doing is in retirement. Oops. Because we cannot even find the files. So we have no clue what is going on. Now, this cradle-to-grave thinking with the digital twin is actually addressing that problem. You really say, I'm bringing together the information over time, and I know what happened over time to my system, so I also know in which state it is now, what is the software now, which parts are in there now, and all of that. So knowledge management over time to keep your systems running as well as your digital twin. So that is addressed in step number 7. And with this, I basically gave you the whole list. And I'm also giving you now for the first time the picture of the core activities of this 7 steps method. So nicely arranged or not so nicely, depending on how you look at it. I like it. They are a little bit color-coded in this picture. You also have this umbrella of purposes around it, and they are roughly placed in this white area so that you know, okay, customer engagement, virtual design, these things are lower left, and optimization, monitoring is upper right, things like that. But basically, the message here is, hey, this is a set of activities that we are looking at when we are building a digital twin. And with this, I introduce the next concepts that I say, okay, now you have seen the core activities for the 7 steps method. So let's talk about pathways. Pathways are basically a notion that for a certain purpose, you need a certain part, a certain path in that graph. So these are the required competencies of the company building the digital twin. And this is, of course, also what opens the door to this readiness assessment. This is the point where I say, okay, if I look at this company and I basically say, this is what they have, and I do understand what is required, I can do the delta analysis. And if I have a delta, if I say you are not ready to do this, well, then I know in which areas I need an uplift, in which areas I can direct you to the Change2Twin marketplace, for example, and tell you, yeah, there is someone who is selling this, so you can ask them. Or there's someone who's offering training in this area, so train your people, and then you are there, and then you can do it. So in that sense, we are going into these pathways now for the remaining of this presentation, and then we take our break. So the pathways are basically the notion that given a starting point, purpose, and goals, I'm expressing the needs. Remember again, this is the consultancy part. So this is Y2ICT, you could argue. And I'm giving you one example here, optimization and monitoring, and you see that I grade out many, many areas of this. So basically saying it might be that simple. So I gave you a big picture. It might be scary one saying, whoa, I have to do all of that. No, wait a second. You want a simple digital twin? You don't. But you will have to have live operations. You will have to have live sensors, and they need to connect So this blue line, for example, is absolutely essential, no way around it. If you want to do an optimization process this once concurrently, no way around it, you have to have that. So this is the notion, a dedicated set of core activities for a certain purpose. Now, let me give you some examples. Smart systems, now this is the big one. Adaptive control based on live data. So the inner digital twin now is part of the system and the processes are live, there's no human in the loop. And you see this is basically the full picture. There's very few blocks missing here. So the pathway for smart systems is a large one. Now, if we are just on the way to a product, so when the digital domain comes first into being, this is model-based system engineering, this is virtual design, this is simulation and analysis. When you are engaging to the customer at the same time, customer build solutions, experience value induced beforehand, this is another part of the story. But in both cases, the pathway to success is a very, very small one. You might go into great details here, but you do not need live operations, live monitoring data, all of that. No, you do it on that side. It's fine. Now, the pathways of bringing systems online, the challenge of commissioning, especially important in either large installations or in installations where you say, this is very fine-tuned configuration fitting to the environment, a lot of parameters in my system which really need to fit to the place where I install it. So this first time on is first time right. That is the commissioning problem. And so here it's very important that on the one hand side we have a match between the physical and the digital twin, and we look into the fitness of the physical to its purpose. So this is a verification and validation process or a live monitoring process where you bring it online step by step and you just check against steps. But in that sense, the pathway, of course, has many parts already inside. We need the virtual part, we need the live feed, but things like process control, change detections, all of that, not there because it's not running yet. You are still building it up. But you might want to have that root cause analysis, which wasn't present in the earlier picture, because if something is not fitting, if you do detect the anomaly and you say, no, this is not how I specified the system, I actually want to find out where did I go wrong, then you have that part. So another pathway is the understanding of the install base, the feedback towards engineering. So here you see that the right side gets a little bit more stronger. So dedicated analysis of an issue, but maybe in concert with understanding usage patterns and their effects. So if someone is constantly switching the equipment on and off, and by that they are using it in a different way and they are wearing something out more strongly, that is something that you want to understand here. Maybe effects due to configuration. Hey, this special piece of my configuration is absolutely fine, and that one is also absolutely fine, but the moment someone builds a system with both of them at the same time, things start to break. That kind of understanding, so that you can do improvements or maybe understand what the next generation of needs is. This is where other parts now of the digital twins rise in importance. So out of a sudden, you have this usage profiling, you have fleet analytics, these building blocks, which are otherwise not necessarily relevant. Another pathway, which we already handled, is of course the one for the live processes. This is what I spoke about earlier in detail when a fast response is essential. So live view on ongoing processes, control based on live data, alerts on issues and events of interest. So the area of scheduling, optimization, monitoring, that you detect something requires an action. Has this pathway. And then we have the one for the guaranteed availability. So especially this area when the unscheduled downtime is a big no. Minimal service times with no breakdowns, everything at the right place on time if you have to do a service action. So nothing like a secondary visit, a service guy comes there and says, yeah, I understand what's wrong, but I don't have the parts, a non-acceptable message here. So prediction of needed parts, of needed actions, of the needed expertise of the service teams. So that, of course, means understanding causes and effects. So this is why the pathway now goes into this area of root cause analysis, but also on prediction, so that this information comes in time. And with this, the pathways themselves are done. So the understanding, and like I said earlier, there's detailed information on that available, but let me finish this part of my presentation with those readiness thinking. So because if we do have this area here that we say the 7 steps, we want to understand now how ready a company is, we basically want to say in each of these areas, how good are you? Now, we streamline this experience a little bit. So instead of saying we want you to ask a company a set of questions for all of these individual shapes, we are basically saying no. 10 sections, and you see them here. So like life sensors, which is the light blue, or the twin fidelity, which is the yellow one. For these 10 sections and cultures, we basically want to assess the readiness of a company. And then we also have the pathways for the main purposes. And then we can do it within the tooling in a ready set assessment. Of course, you can always do a more detailed assessment by a savvy consultant. That is always an option. So you can say this customer really needs to understand a certain part of this graph in detail. So we will look into this, maybe also because in a certain innovation hub, you really have the expertise to go deep into something and you really want to offer something here, absolutely fine. But based on the tooling that we offer right now, we streamline this a little bit. So we are talking about these sections which you see highlighted here. And then the idea is like this. We are matching the readiness levels. We have the requirements to succeed, and we're doing the delta analysis with the assessment of the readiness level of a company. So we might, for example, say, okay, there's a set of numbers popping up in these boxes, and there's a set of numbers popping up for the pathways that we believe we need. And we just say, hey, wherever you are lower, you have to do something. In that sense, that's simple. We are always using 6 comparable levels. So 0, absolutely nothing, X, absolutely everything is there, which is imaginable, and very often you will not need a 6. And these levels, they are based on these digitalization levels, which were developed for the smart industry. And you have also seen this picture yesterday already. So the questions we are asking, the informations we are after is always similar to this. So we are following this, but of course, this is an overview picture here, and the moment you go into a detailed picture, you can ask the questions more specifically, but still, in terms of these levels, we basically say we are following this idea from there is nothing towards everything is already automated, live, and in an adaptive way. So we see that there's a certain, let's say, order of things here where you say, you can understand it that in the top 2, if someone is in that area, they are just not there yet. They really can't do a digital twin with just having some digital documents, but no digital processes whatsoever. But the moment you go to the level 2 and 3, we are in the area where you say, okay, connected information, digital processes, maybe already the live data view, level 3. This is where twinning starts. But this kind of twinning only gives you awareness, and then a human in the loop acts. With level 4, we are talking about twins where the digital processes that consume live data come into place. So automation becomes possible. So response within business or twin processes. So meaning it could be that the service process is automatically triggered by the twin, but then still the humans do it. But it could also be that the twin itself is already taking actions, filling out order forms or whatever, because it just knows what parts will be needed and things like this. So levels 4, 5, 6 are the area where automation becomes possible. Digital processes that consume live data are in place. They might become predictive. This is then the next level, number 5, or even fully automated that change operations. So the area of the twin which takes decisions. That is then level 6. And so we always follow the idea of 6 levels like this. So when you do an assessment following these ideas, there are a few attention points which I want to announce now. So first, you can imagine when we are talking about all these different parts of the graph, from data to business processes and so on, you see that the interview might need replies from several stakeholders. Now, it's absolutely possible that there's a small SME that says, no, we do have a CEO who is in every bit and detail of our company. He can answer that all. Absolutely fine. It's possible, of course. However, it might also be that that CEO says, okay, you know, I did the business analysis with you yesterday with this great tool from Laura, but these kind of questions, I have no clue. So now I'm calling in my lead people for these areas, and you all get half an hour with them because that's all it takes. And then the interview is over in that way. Another attention point. We observe a trend to overestimations in self-assessments. So principally speaking, this could be done without a consultant. You could just say, okay, hey, these are example areas. What do you think? Where are you? Now, people like Jeroen, our own experienced consultants, they find, hey, if I look at this, I would have given you a lower number. So in that sense, we caution everyone against an overestimation here. Take it with a grain of salt and maybe err on the cautious side a little bit. On the other hand, in this assessment, we check against the minimal readiness level to succeed. That is not the statement that having more would not be better. So you can easily imagine that there is a point where you say, now I have a running digital twin and it's running on that and that level. But for example, it's just showing what is there now. It did not make the step from 4 to 5. It did not go to predictive. Now, if it would, the business success might actually be far greater. But it is a success already on level 4. So in that sense, the check we are proposing here is against the minimum readiness level. So whenever our check says you are not there, we really believe, no, the company needs to make a step. But as a consultant in a digital innovation hub, I still say the level for optimal benefits is often 1 higher, normally only 1. So still think about it. So just the fact that we give you a nice presentation and a tool and everything would never ever mean you stop thinking. So that is the point where people come in, experts come in, and I believe this is the game the digital innovation hubs play best. So I wish you best success with that. We will take a break now, and then we will actually see the tool a little bit, and then I also give you the more detailed information. So if there are questions, So I'm the one here on top, Michael Borth. So of course you can get in touch with me if there are questions. I'm working for ESI. This is a subdivision, a joint innovation center under the umbrella of TNO. And when you go to our website, so ESI&L, for example, you can also easily find more information what we think about it. But remember, we are a research innovation center, not a digital innovation hub. However, Jeroen, of course, you get to know him yesterday. He is a consultant of us in the area of ICT. So the process of doing consultancy with this work is something where he can give excellent advice upon. But in terms of material, and I will show it to you after a short break here, and we still basically have three things now. On the one hand side, we have the tool itself. So similar to what Laura showed you yesterday, an assessment tool. Next to that, there are two presentations here, the assessment presentation and the pathway presentation. They have a different content, and I will show it to you a little bit later. So there is the last part here of my time slot where I show you basically which material is available to you. But the idea here is that the pathway presentation explains to you our thinking about the numbers on these pathways. So the moment you say you are assessing a company and you have the feeling that none of the pathways that we already prepared is suitable for that company, they want a different digital twin. This is basically the statement you're making. They are more unique than our pre-compiled cases. Then you're working on that level of that pathways. You are finding out new numbers of what these guys might need. Now, the other presentation, the 7 steps assessment presentation, that is the one that basically tells you this is the kind of concern which is in that area. So when you're assessing this, this is the kind of topic you are talking about, and this is the kind of question you are asking to assess if someone is on that level or not. And I will show you that a little bit, and it makes perfect sense. For example, to have the assessment presentation open while you're asking question and then filling in the answers in the tool. So just as a way of working. But if you need other numbers, the pathway presentation gives you some pointers on that one. And with this, allow me to call a break. So I talked for an hour.